So we'll be doing the lab today. So for what all we discussed previously. So I'm expecting this to be a short one itself. So let's see. So let me just open the topology for you. Um, Let me know if you're able to view my screen.
No, not yet.
Okay. Yeah. Can you see it now?
Yes.
Yes, yes, Prajwala.
Okay, thank you. So can you guys just take a screenshot? It's a simple topology, just for the interfaces in case you need. So we have two hosts that's connected to our 7130 LBS switch. Uh, so for ease, we have kept the interfaces on both the switch 7130 and the normal switch to be the same. Okay. And here, there's one link, we've kept it as L2, and the other link is routed. So let me know once you're done with the screenshot so we can proceed with the lab. Can we proceed?
Yes.
Fine. So here we have the 7130 switch, and here we have the other two, CO633 and the CO632. So ET 14 and 15 go to CO633, and sorry, 13 and 14 go to CO633, and 15 and 16 to CO632. So now, first we need to start by running the switch app, right? So first, how do we check? You know the procedure to install the switch app, right? Same as installing an extension. So the way to check if you are running the application, any application here on this 7130 LB switches, the command show FPGA switch. So as you see here, we're not running any uh, s- uh, a switch application here as of now. So that's why we'll have to do it. First, we need to check if the switch application .swix is present in our extensions and if it's already installed or not. So as you see, we have two switch app versions. This is the latest, but we'll be doing our tests on 1.3.1 version. So as you see, I have installed this because this is what I want to use now. Okay, and I made sure that this will be persistent across reboot. So once you make sure the extension is present and installed, all you have to do is just go to the switch mode and then first choose which profile you want. So you see, all of these profiles is something that we discussed in the previous session, right? So we'll start by testing the layer 2 feature. So that's why I'm choosing the layer 2 full profile. Okay, and you have to choose a port layout, which is just 48 cross 10G. And then here you don't really have to specify the FPGA because it's a single FPGA device. So if it's multi FPGA, you'll have to specify it. So here I'm just putting an enter. And then once you choose the profile, you just have to unshut it. The command to unshut is no disabled. So once this is done, again, it's time to check if it's programmed. So this is the command. We're not seeing it here yet because it takes a couple of minutes to program. So while it is not programmed, let me just show you the show interfaces status command output. So this looks very familiar to you guys, right? You just have all the ports ranging from ET1 to 48. And of course, the management interface. Once it gets programmed, let's see how it looks. Okay.
Is there any command to check what's the programming status? Like if let's say it fails while programming itself and here we do not see any output at all, then what to
Uh,
check?
you will have to check the logging, sys logging, this
Okay.
show logging system output. That's something that we can do. but now it's installed successfully. So as you see, you can see the application and what is the profile that we've chosen. The port layout is definitely only one option. We have 48 ports with 10 GB each running. Okay. Yeah. So now let's get started. Now let me show you the show interfaces status output. So until this, these are the physical Ethernet interfaces. Now you see you got all your switch interfaces. Okay. So switch 1/1 is mapped till 1/48 is mapped to ET1 to 48. But there's one switch interface 1/49 which we discussed, that is connected to the CPU. All right. Okay. And one more thing, guys, I don't know if I missed telling you this. In case you want to change the port speed from 10 gig to 1 gig, let's say you're doing it on any of the switch interfaces, then do make sure the associated physical interface is also changed from 10 gig to 1 gig. Otherwise, the speed won't take an effect. Okay. All right. So now it's time to look at the mappings. So let me show you this way. Yep. So you see Ethernet 1 mapped to switch 1/1, and which is internally mapped to the application interface 1/1. Okay. And these interfaces, you're just seeing the source as MAC, and the reason is these are either shut down or, basically the links are down. So that's why you see it like this. But otherwise, for rest of the links which are all up, you see the mapping. So the mapping is pretty straightforward, 13 to 13, 14 to 14, so on. Okay. And the mapping other way is also given. So this is because, as we discussed, this is bi-directional thing, right? So from switch to physical interface, it's a bi-directional thing. Let me just to reiterate, this is how it looks. And so that's why both the way mappings are shown. In case you were to change any one of those mappings, then you will see a difference here. Okay, let us test the same out. So yeah, here are the four interfaces that we are going to mainly operate on. Which are the yeah, switch interface 13, 14, 15, 16. Okay, because those are the four links which we're working on. So let's play around with the same. Let me do one thing. So I'll say switch interface 1/14 take source from Ethernet 13. So this is how we do switch 1/14. You say you call it L1 source Ethernet 13. Sorry. Now let's see. Here on the Ethernet interface, there was no change. So there's no change in the mapping. But if you look at 13, if you look at 14, you see the source is Ethernet 13 and not 14 now. Now let's check this. Show L1 destination. Yeah. Now you see whatever's coming in on Ethernet 13, it's a destination to two interfaces. That is switch 1/13, which is mapped by default, and also switch 1/14, which we have configured. Okay, so this way it's very easy to understand the flow. Any confusions here, guys? Are we clear?
Can you repeat that once, Prajwala?
Okay, sure. So what we've done here is I went into switch interface 1/14. Okay. And so by default, what is it mapped to? Ethernet 14, right? So instead I said L1 source. So your source is not going to be Ethernet 14 anymore. I said your source is going to be Ethernet 13. Okay. So based on
Okay.
this, if you look at show L1 source, you look at switch interface Ethernet 13, 14, sorry. What is it calling itself as? What is the
Source.
source? it's
13.
13, it's changed, right? But here, if you see for Ethernet 14 and 13, it's not changed because the source for these interfaces have not changed. Okay, wherever we have changed the source, only that is being reflected. That is this. Now, an
Okay.
alternate way to understand this is by looking at show L1 destination. So, on the above command, you saw it's where the source is, right? Like for from where am I going to get the traffic for a particular interface, you'll understand by looking at this. But when you look at show L1 destination, it means whatever is coming into this interface, where all am I going to send out, right? So if you look at Ethernet 13, by default, it will definitely send out on switch 1/13, right? That's the default mapping. But alongside, because of the change that we made, it's also going to send it out to Ethernet 1/14, switch 1/14. So it's like this. No, actually, it's not there in the diagram. So you can imagine this. So Ethernet 1 is going to send the traffic to switch 1/1. Okay. Now let's say on switch 1/2, if I say source Ethernet 1, then whatever is coming from Ethernet 1 will also enter switch 1/2. It's like there's a line here on the blue, from blue to blue. Is it clear now?
Yes, Prajwala, thanks.
Okay, no problem. Okay. Um, so now that we have done the change, it's time to get it back because we need to work on that. So one way is, see, if you want to change it one way, like the sources one by one, then you can do just this command, just do L1 source and you'll be done. But what if you want to change the whole in and out mapping? Like here, one is mapped in and out to switch 1/1. Now, if you want to map Ethernet 1 to in and out to switch 1/2, you have two ways. You say switch 1/2 source Ethernet 2 and Ethernet 2 switch source switch 1/2. But instead of that, you can always use the connect command. So right now, what we'll do is to get this defaulted, I will say L1 connect Ethernet 14 to switch 1/14. So by this way, both the sides connection will be restored back to switch 1/14. So now let's check this. Switch 1/14, the source is Ethernet 14. Right? So you got the difference, I hope. Otherwise, let me know, I'll repeat it. So this is to connect the interface both way. Now, if you want to check this, let's do this. Now I have connected switch 14 to switch 1/13. So now let me do show L1 source. See, the source for Ethernet 14 is changed to 1/13. And also here you'll notice that source for switch 1/14 is changed to Ethernet 14. Okay, so it's both the way around. So it's just a single command that makes it easier. Now let me, okay, and rather, so now let me connect it back to Ethernet 13. Sorry, my bad, 1/14. We should be restored now. Clear with this, guys? Any doubts? Please let me know. Okay. So moving forward. Yeah, apart from this, you can also look at the mapping with the help of a matrix. It's just easier to read. It's just the same thing, but you'll have the connections. So this is ET to ET mapping. We have not done any ET to ET cross connect here. So we don't see anything. But you see Ethernet 1 is mapped to 1/1, Ethernet 2 is mapped to 1/3, and so on. So this is the mapping. So this is a continuation because not all 48 ports can be shown right in one output. So that's why. Basically, it's the same thing. It's just a kind of a graphical representation. Okay. Uh, so again, I'm reiterating. So whatever we do on the Switch app, right, we'll not be using Ethernet interfaces anymore. Everywhere we'll be using Switch interface. Okay. And the only time we're going to touch Ethernet interface is when we're doing the L1 part, like changing the source or something. Otherwise, we're not going to do anything with the Ethernet interfaces. So so most of the commands are very, very similar to what's there in the EOS. Okay, but only difference is instead of using Ethernet, you'll be using switch ports. Okay, so like how you do show interface status, show interfaces, right? So you can check the same thing here. Show interfaces switch 1/1. So you see, very similar kind of output is shown here. And you can all LLDP is also run. So on the LLDP as well, you'll see the switch mappings associated with the neighboring mappings of the other Ethernet devices. So now let's start the other test. So let me open the diagram. So as you see in the diagram, we have kept one link as L2. Okay, Ethernet 14 and 16 on this LBS device are all L2, but IP address is configured here. Okay, so we'll be initiating a ping and let's see how Mac learning, and next we'll try with an L3 and see how ARP learning goes. So we have 10/112 on host 1 and 10/113 on host 2. Let's ping and give it a try. I'll be pinging 10.1.1.3. Um, these are the L2 interfaces. So let's check it. Okay, sorry. It's
Hey Prajwala,
yeah,
just had one question. When you run, maybe this was already discussed, but when you
yeah,
ran show LLDP neighbor output,
yeah,
in that the output had the interfaces as switch interfaces, switch app interfaces, right?
yeah, yeah. Yep.
But for the neighbor, let's say DBE, it shows the physical interface Ethernet 25. So if we connect two switch app devices, would
Hmm.
we be seeing switch interfaces on both the sides?
Yeah, that's what it looks like. We
Okay.
should, yeah, we should be seeing switch interfaces, but
Interfaces.
we never got a chance to get
Okay, okay.
two devices, so I could not test them.
Got it, got it. Okay, okay. That's fine. Yeah. Thank you.
No problem. Uh, okay, so checking the configuration. So Ethernet 13 and 15 are the ones. Okay, because there's a command that I had configured and I had not removed, right? So this is where it's happening. Okay, let's ping it again and see. Not working. Okay, it is layer 2 full. Okay, fine. I'm not going to waste time debugging that. So we have another L3 interface, okay, where you have different subnets configured. So ideally, guys, you should be learning the MAC address here. So for the previous thing, I'm not sure why that is not working. Okay, you see, it's here. Switch 1/13 and switch 1/15. I'm not really sure about the ping. It was working till yesterday. So I'm going to ping the IP addresses here. So we have 20.1.2 on this switch. Okay, and we have 30.1.1.2 on this switch. So the route to reach this is via this interface, Ethernet 16, which is mapped to switch 1/16 here. Okay, I just did the ping and it was successful. So let us check the IP addresses here. As you see, we have dot one subnet here, dot one IPs on switch 1/14 and 16, and it was routed successfully. So you can check the R, right? You have the ARP entries. So all of this is pretty much very much similar to EOS, just that the interfaces are the switch interfaces now. Okay. And alongside you can also configure port channel. Since I don't want to modify the configurations, I'm going to configure a static port channel and just show you. So just channel group, 10 mode. You have all the three modes, but I'm just going to choose on. Okay. I don't know why I did not notice this. 1/14 actually has an okay, yeah, never mind.
What does that error message or warning means?
Sorry.
TCL confused. You got an warning, right?
Yeah,
Something.
that is because now see when I put it under port channel, then these configurations are not going to take effect, right?
Right.
The access, right? So that's why it's giving a warning so that in case we want to configure the ACL, then we'll need to do it on the port channel, just like an informatory warning.
Okay.
It just says it's overridden by port channel 10 config. So unless you make this interface go out of port channel 10, these configurations will not be in effect. That's what it says. But the port channel is created. Okay? We have the port channel created. Only thing why it's throwing the warning is like some significant things like ACL uh, might be security ACLs, right? For the customer. So in case they do not notice the config and they just put it under port channel, then the access list is not applied anymore and can cause some issues for them. So that's why this kind of a warning is thrown. So you see port channel is created. This is just to show you an example with the switch ports it's created. So I'm going to remove it. So we can also run MLAG, VRP, VRRP, but of course we do not have two devices, so we'll not be able to test that out. But it's more or less very similar to EOS itself, so there's no difference that you will notice really. Okay, and we also have this command, which one/16 hardware.
Yeah, whatever changes that you made now, I think the thing started working all of a sudden.
10/1/
Yeah,
okay.
maybe it's taking some time to program.
Maybe, yeah, I think there was the source command was given wrong when I was just showing it. Fine, thanks, Arjun. So yeah, guys, the
It
ping
will
is
not do anything.
working. Check the MAC address table. Anyways, yeah, this thing we already checked. So okay, yeah. So I was talking about this one, show interfaces switch 1/16 hardware. So you'll see what are the speeds supported and if there's flow control enabled or not. Okay, so this is the information it gives. So you can always change your speed, but make sure to change the speed on both switch interface and the physical Ethernet interface. Okay. And along with this, you also can create an SVI. And I think I have I already have one. It's all the same command. So I have an interface VLAN. I've given um, IP address, and then we have an ACL. Everything same like how we do on the US. And when you look at what is enabled here on VLAN 10, you see there are two switch ports enabled. Okay. So all clear until now, guys. Please let me know if you have any doubts. Okay. So we will actually we can check the IGMP related stuff here because we're running the L2 profiles, but we'll just do it alongside with the multicast. So we'll just change the profile now. So before I change the profile, let me know if you have any doubts. So I'm just moving ahead. So first to change the profile, you go to the switch mode and then you have to first shut it down. That's called disable here. Otherwise, you'll not be able to change the profile here. So now I'll be choosing the layer 3 mid latency. Port layout. And I'm going to unshut it. Let's give it a few minutes to get programmed. And in the meanwhile, let me show you. We already have BGP configs here, just to save time. So we'll quickly have a look at BGP also. So okay, this is what we have. So let us check. It's programmed. You see, the profile is layer 3 mid latency. So now let's quickly do this. Not sure if I already have it. So our neighbors here are 2111 and 3111. So it is, sorry, it is 2112 rather. So 2, and the remote AS there is 2. The remote AS here is 3. We have it established. So IP. So the BGP neighbor output command also is something very similar to what you've seen before. You have the version, router ID. Everything is exactly the same, guys. I just showed it to you for reference. Okay. Mm, So let me just open up this so that okay. So we can also configure access lists here. Okay. So let us do one thing. Let's configure something to block the ping. Okay, of the L3 packets. So I'll say it. I'll call it ping block. Okay. So here when I will be applying it on the, so only ingress ACLs are supported here on this platform. So you can apply your ingress ACLs on the routed interface or SVIs, okay, or port channels. But there's one limitation to it. So when you apply, um, so I hope you remember the concept of pipelines, right? So for each pipeline, only 16 ACLs are possible. Okay, so just to show you, make you visualize the diagram. For example, let me take the mid bandwidth profile because that's what we're running. So you have different pipelines and 4 ports mapped to each pipeline, right? And so you'll have around 12 pipelines like this. Now, for each pipeline, a maximum of just 16 ACLs are supported, and for each ACL, the number of rules supported is 45 for each ACL. That is before expanding it. Okay, so if you expand it, furthermore hardware resources are consumed. Now, while we can apply it on physical interface and SVI, there's a difference because when you apply it on physical interface ingress, let's say this is 1/1. So if I'm applying it on 1/1 ingress, then the ACL is programmed only on this pipeline 0 because 1/1 is just present here. But now if I configure it on an SVI, now the SVI can have multiple interfaces from multiple pipelines. Let's say I have one interface from each pipeline. So now when I configure it in SVI, then each of the pipeline will have that ACL rule configured. So it's like you'll have a total of 10 entries on the switch. So, I mean, using SVIs to program the ACLs can be a bit hard, a bit resource consuming. So that will have to be done very wisely. Okay, so I just wanted to highlight this point. So right now, let's just create a ACL and put it on the L3 interface. So let me just deny sources what 30.1.1.2. The way we do it is all the same. Key host. So I'll be running ping from here, and here the address is 3112. I'll be blocking the ping to this device. So the destination would be 20.1.1.2. IPNENE. Actually, the counters per entry is supported on this platform given there are sufficient hardware resources. However, it was not able to work for me, so we're checking further on it as to why it's not working on this. Okay, so this is the configuration, and ideally it should work. And now we'll be applying this ACL on any of the switch interface. Here, the right interface would be IP interface brief. So that is switch. So since we're applying it on the ingress, it will be switch 1/16. The access list, ping block in. Okay. So now let me run the ping and check 20.1.1.2. It's not working. So you had already seen that this was working, right? So but now because of the ACL it's blocked. Okay. Okay, we just got lucky because I was seeing incomplete statistics and I was not able to see the matches, but now we do. Okay. So this is about ACLs. We also permit standard ACLs. We can configure this on the device. So that we'll be using it for multicast boundary ACLs. We'll just do it now. So first, let me remove it. Okay, the ACL is removed and the thing should work now. Okay. Yes. So even when we do have multiple limitation when it's come to configure ACL. Let me just show it to you. Oh my bad. Okay, the most important one that you have to remember is that when you configure it in SVI, then you will be configuring it on the every pipeline wherever those interfaces are. So basically those interfaces which belong to the same VLAN, and wherever that is in the pipeline, so each of them will have an ACL entry present. Okay, and one more thing that you have to remember is the NAT ACL and the security ACL, both of them share the same hardware. Okay, so the numbers that you're seeing, like a maximum of 16 or basically the rules maximum of 45, is a combination of the NAT ACL and security ACL. Okay, and yeah,
What was, sorry, I didn't get the previous one which you mentioned, right? The important one. I
the
didn't understand that.
okay, the pipeline programming with the SVI, right?
Yeah. Right.
Okay, sure. So now if you see when we program the ACL on an L3 interface, what will happen? We'll program it on any specific L3, let's say switch 1/3. Okay, where is that present now? On pipeline 0. So that
Yes.
particular ACL will be just programmed on this pipeline 0. Okay, now let's say we have an SVI interface, a VLAN SVI 10, right? In that SVI 10, we can have multiple ports, right? L2 interfaces. So let's say I have
Yes.
one interface from each pipeline. So first pipeline, let's say I have 1/2. Second pipeline, let's say I have 1/6. Third pipeline, let some random switch interface I have. So like this, let's say we have total of 12 pipelines, right, in this profile. So let's say we have
Yes.
each interface on every profile that belongs to VLAN 10. So now if I go to SVI and if I apply an ingress access list, then that will be programmed on each and every pipeline.
Okay. Okay.
Yeah. So totally there'll be 12 ACL rules programmed with one programmed on each pipeline. So
Okay. Okay.
wherever you have the interface belonging to that VLAN, on that pipeline it will be configured. But on the other hand, let's say only first four interfaces are a part of that VLAN or that SVI. Okay, so in that case only one rule will be programmed in pipeline 0, and the rest will not have the ACL configured because there are no interfaces belonging to that VLAN 10.
Okay. Okay. I got it.
Okay,
Thank you.
no problem. Any other doubts, guys? Okay. And another important thing that you should remember is, since ACL and L3 share the same resources, you will have to have either the source or destination IP prefix in the routing table. Otherwise, the ACL will not be programmed. Okay. So there's a total number of ACL entries that they've given. So that is just a multiplication of 45 and 16. That's like the maximum. Okay. So this is about ACLs. So now let's move on to multicast. So let's start with IGMP first. So here we have two interfaces as part of VLAN 10, right? So yeah, these two interfaces are a part of VLAN 10. So they will accept the IGMP report and they should be creating a snooping entry. So let's check if it works. So I already have the configurations here. So I just have to. So I'll be generating reports from this interface, Ethernet 16. Okay. I think so. Yep. So I will be trying to join this. And so this is the group ID. So this host wants to join to 239.2.2.2 group. And we'll have to specify the egress interface from which the report needs to be sent. So this is the command. Okay, so once we run this mtest, we should be seeing a IGMP report on this device. So based on that, we should be creating a snooping entry. So let's check. The commands are all the same. See, we have switch interfaces 13 and 15 because those belong to VLAN 10. So you can check the detail output also. Okay. These belong to VLAN 10 and these are the members. Okay, it's very similar to what you see on the EOS switch. And you can also check who are the M router ports if you have. So these are the M router ports because we have PIM enabled on these two interfaces. Since PIM is enabled, we'll receive queries also. And so that's what makes it as M router ports. All right. So now that we have it, so we also have an SVI, I told you, right? VLAN 10. So I have configured PIM sparse mode on this SVI. Okay. So you know, right? So when we have PIM sparse mode configured, then this is a multicast switch. So we will try to send joins out to the RP. However, on this device, I've already configured this device to be the RP. So we do show IPPIM RP address. Show IPPIM RP. The RP is 1111. Okay, that's for all the multicast groups. So you can check the IP route. The command to configure RP is the same IPPIM RP address 1111, and this 1.1 is present on itself on loopback 1. So it knows that this is the RP. Okay. So now I don't know if this has timed out. So let me send the report again. Yeah. So this should have created an M test, M route. So the OIL is switch 1/16 where the report was received. The IAF is register, and the reason is because this is an RP, right? So since this is an RP, the IAF is register. So this will proceed further once we get the multicast feed. Okay, so let me just start sending the multicast feed from CO633. So we're trying to make this device act as LHR, FHR, and RP because we don't have multiple devices here to test with. So let me just get this. I started sending the feed. So this is 239.2.2.2 and the source is local to the device. So let us check the M route. Okay, see here, we have the source and the incoming interface is on switch 1/14 because ET14 is connected to this device, and we have the OIL. The flags are all clear. I mean, the flag, everything remains same as EOS, so there's no change. S, it's SPT. L because it's locally connected, and P is for programmed in hardware. And you see, there's no C flag, so that means it was not registered because we don't really have a FHR who is registering here. Rather, we're just pumping the feed directly. So the C flag is not here. Okay. Any doubts here, guys? So we'll test multicast boundary axles now. So multicast boundary axle is just something that blocks unwanted multicast traffic from entering and creating M route states on the device. Okay. Now let's say there's an unwanted source pumping in unwanted multicast data. Then what will happen? There's a potential for it to create an M route. And in case because we start consuming resources, or maybe we want to block it explicitly, in that case we can make use of MBR. So you can configure it both on the side where you're receiving the traffic or where you're receiving the reports. So configuring it on any of the interfaces will block the multicast route from being created, or basically the route won't be, I mean, basically the traffic will not be forwarded out. Okay, so our aim is not to forward the traffic. Either if you're receiving the reports, then let me not create the join, or if you're receiving the multicast feed, then we'll not send it out of the OIL. So that's the concept we have. So it's just to block multicast traffic. Okay, but we have a difference. So you can configure just the multicast boundary with the help of IP multicast boundary and the ACL, which specifies which group you want to block. And the same thing can be configured with the keyword out. Okay, the word out does not mean we configure it in the outer direction or something. The word out means programmed in hardware. That is what it is in US as well. So on 7130 device, so basically when you configure multicast boundary ACLs, the way we're going to discard the traffic is with the help of fast drops. Okay, so let's say we do not configure with the keyword out, then whatever multicast packets come, they're first sent to the CPU, and then the CPU has to program the fast drop entry, software fast drop entry. And once the fast drop entry is created, then we'll start dropping the packets in hardware. But if we configure it directly in hardware, then as soon as the traffic is received, then we just create the fast drop entry and then we start dropping it. So that's one difference. And one more thing is, let's say you clear the M route, or for some reason the M route is getting wiped out, or there's some route churn. Okay, because of that, when your M route is affected, then your ACL, because the fast drop entry is also affected, the ACL will get affected. There'll be churns. But if you configure it in hardware, and even if you clear the M route, then the multicast boundary ACL entry will not be affected. Okay, so let us give it a try. Okay. So first we need to create a standard ACL to block whichever group we want. Since we're running 239.2.2.2, we'll block that. So I'll be calling it. Okay, so I'll be saying deny. Deny host. Deny. And now what I'll do is I'll be applying it on the IIF. Okay, our IIF is switch 1/14. Let us see how it works. Command is the same, multicast boundary. And then you can either specify the group or you can just specify the ACL name. So I'm not giving the word out. So when you're testing it, I don't think we can see any significance like in the time it takes or anything. So just doing a software one. So now I've configured the multicast boundary ACL. So let us see. Okay. So you see, we are getting the traffic. However, the IAF is not um the ET1/14 anymore because we have applied the boundary ACL. So let me take another session on the switch and see if we're receiving the traffic or not. So I already have monitor sessions configured. With the net 16, we have it. So let me start taking it down. S16. As you see, we're not receiving the multicast feed. So we're just blocking it, right? Okay. So I will be removing it now from 1/14 and then we'll see seeing the feed. See, as soon as I remote, we start seeing the feed. Now let us apply the same thing on the OIL interface. Mm, Now again, as soon as I applied it here, you see the multicast feed stopped. I mean, the host stopped receiving it. So let me check the mRoute now. So you see the OIL is not there. We're receiving the traffic continuously, but the OIL is not present. Right? So, and it's reverted back to normal. Okay. Yeah. So I think we've covered pretty much everything. Yeah. So this was just to give you some idea about how you can work on the switch app. There are few things that initially, you need to understand, and rest of everything the same as your other EOS switches. So there's nothing special that you need to learn about, like, the commands or the protocol specific things here. Just always refer to this, the TOI, for any limitations or any issues that you or the customer hits into, because there are definitely limitations for every feature that we have, and we are trying to improve and then fix in the upcoming releases. So keep a reference of this, but otherwise there's no difference as such in terms of configuration or anything. Okay, so this was just to give you an idea. So that is it from my side, guys. Please let me know if you have any queries. We can discuss it right now. Anyone, any doubt? If you want me to repeat anything, please let me know. Okay, so, okay, that means I take it as no doubts from anyone. So we could finish it before time today at least. So, yeah,
Thanks, Prajola,
no
for
problem.
taking the sessions. Thanks.
No problem, Vishal. We'll be having the 7130 LBR platform training scheduled next in the upcoming weeks. So we'll keep you posted on that.
Sure. Thank you.
Thanks everyone for attending the sessions. Have a good day.
Thank you, Prajola.
Thank you, Prashana.
Thanks, Prajola.
Thanks, Prajola.
Yeah, thank you.
Thank you.